All right, welcome to another video, and in this lesson we're going to go over quadratic inequalities. It's very similar to what we were doing before with the compound inequalities from a few chapters ago, and we're also going to pay attention that we have to pay attention that we have to the fact that we have a parabola going on technically. And let me show you how to do these. So if they ask us the graph, we'll be ready. Anyway, it says the polynomial inequality x squared plus 11x plus 24 greater than 0 can be solved by first solving the equation. It would be the same function equal to 0. So let's hope that they let us slide with that. That's what I would do. That's what we would all do. Set it equal, treat it like a regular equation without the alligator mouth, without the inequality. Okay. The real solutions of this equation, -8 and -3, shown on the number line, are called, okay, these are the real solutions. Boundaries? Let's see. Yeah, these are the boundaries, not the test points. The test points are the numbers that you use in between, to the left, to the right. They're not part of your answer, but you use them to get your real answer, and you're going to see what I'm talking about in a few minutes. Okay, the points at -6 and -4 shown on the number line below are real solutions, blah, 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 blah. All right, there are boundary points. The points that had -6 and -4 divide the number line into 3 intervals. They're asking us the question. Yeah. Okay, so they're setting you up to get into the mindset of what we're doing here for our test values to see where we're going to shade, basically. And yeah, so from -infinity to -6, that's going to be one region. Then in between -6 and -4 is going to be another region. So we have it here. And then the last region is -4 all the way to infinity. So 3 different spots. If we have 2 solutions, you're going to have 3 different sections of that graph, of that number line. Fantastic. And notice something. We have our bracket right here, right? Whenever you're using test points, everything is just going to be parentheses, non-inclusive. You don't want to include the value itself, like the real value, the possible value. So all parentheses, okay? Okay, now we're going to solve it for ourselves. Now it says solve the inequality. What is the solution set? The solution set, well, basically, all right, they says solution set. So I guess, are they talking about just 3 and 4? So remember, the solution is the opposite of this and the opposite of this. Now, they never say interval notation, so I think they want just the numbers where you set this equal to 0 and solve for x. So remember, the answer is just going to, when you factor it up, which is already factored up, is going to be the opposite of what we have here. So let's just write 3, comma, -4 and see if they let us get away with it. Oh. Okay, simplify your answer. Oh, it does say use interval notation, derp. Let's go ahead and do it as intended. Okay, so all right, so we have x minus 3, x plus 4 greater than 0. And remember, the first step is to just pretend like it's a regular equal sign, like a regular equation without the alligator mouse for a second. Right? So what are your solutions? Is the opposite of this. X is equal to 3, and the opposite of this, -4. So there go your 2 solutions. I call these your key players. And we're going to make a number line like so. And we're going to put our key players down where, with respect to one another. Then -4 would be somewhere over here, and the +3 would be here, right? So now what? So we have these points here. And now we're going to go ahead and shade according to whatever is true. So we call these test points. So remember, this is -infinity. This is +infinity. We have 2 solutions. So we have to check somewhere in this region here. We have to check somewhere in the middle. And we're going to have to check the end. And the way I'm going to show you, I don't want to waste your time. I'm going to show you the somewhat longer way first. And then we're going to use that to, I guess, get the rest of our answers. Okay. So let's go ahead and find some test points. Give me a number between -infinity and -4 we can choose something like -5, -6. So I'm going to put -6. Let me use red. I'm going to use a -6 and put like a box or something like that. Like it's not really a part of our solution, but we just use it to know which way we're going to shade. We're going to do the same thing with, and that's a little bit too robust. Let me put it down here. Okay, another test value between -4 and 3. We can choose 0. 0 is always in between a negative and a positive. And give me something greater than 3. We could choose 5 or something, or 4. Anything that's greater than 3. So basically, it's like, how do we know if this is true or not? You basically plug all of these solutions, all of these test values into your original. And if it ends up being true, if you find out that, for example, 5 is greater than 3, then that will be the answer. So this is the longer way. And you're going to see we're going to narrow it down just a little bit. So let's plug -6 in. That'll be -6 minus 3, -6 plus 4, greater than 0. We want to see if this is true. -6 minus 3 is -9. This is -2, right? Greater than 0. This is 8, positive 18 greater than 0. Is this a true statement? Is this true? Is positive 18 greater than 0? Yes. And we got that from testing -6. So everything in this region would be true. So you shade all of that going to your negative infinity. Now, spoiler alert, okay? If the left-hand side over here worked, then the right-hand side over here is also going to work. Don't take my word, though. You want to test all of your test points individually and make sure that you know. That's for the people who are comfortable with the math. And if neither of them work, then the middle usually works. But I want to say it's 99% of the time. This is a disclaimer. I want you to test all 3 of them. I've done a few of these, so I know what's gonna happen. Sometimes the answer is no solution. Sometimes it's all real numbers. But anyway, let's test the 0. We're gonna put 0 in here. So this is my testing notation. That'll be 0 minus 3. 0 plus 4 greater than 0. That'll be -3 times 4, right? Because 0 minus 3 is just -3. That'll be -12 greater than 0. Is that true? No, it is not. -12 is not greater than 0. So we are not going to shade in between -4 and 3 because we plugged 0, the test value, the representative value, into our original, and it didn't work. -12 isn't greater than 0, so we're not going to shade in between. All right, we're going to plug the 5 in, and we're going to use mental math for this one. Remember, we're plugging the 5 right into here. So 5 minus 3, I'm going to do something a little bit different. If you plug a 5 in here, wouldn't that be a positive at the end of the day? That whole parentheses would be positive. You plug a 5 in here, wouldn't that also be a some positive number? And we're trying to see if it's greater than 0. So without worrying about what the numbers are, is a positive times a positive greater than 0? The answer is yes. So you will shade over here, and look at that. We were right. So the solution set, what's the interval notation? What are we going to put a bracket or a parentheses? That tells you what to put. So because it's not equal to, we're going to put parentheses on those key players there. I'll be neater in the next example. So the solution set, the interval notation is going to be -infinity to -4. We have a space, so put your union. And let me erase some of this. I probably should have did it different. I'm just so sloppy here. Then 3 to infinity. That's it. So let's go back to reality over here. -infinity, comma, -4. Union with 3 all the way to infinity. Fantastic. Okay, whichever graph matches up with ours is the one. Looks like it's this one here, right? Let's see, 1, 2, 3, 4. Yep, -4, and this is +3, so that's got to be it. All right, next. Okay, x minus 1, x plus 7. Let's do it. So it's already factored up, so it's ready to go. So let's use orange this time. Mostly all of my videos are in orange. Okay. So key players, x is equal to 1, and x is also equal to -7. So these are our key players. Now what? Test values. Give me something to the left of -7. How about -8? What's in between here? 0. 0 is nice. What's over here? How about 2? And we're going to test to see if it's true. Ready? So remember, we plug all of our test values into the original with the alligator mouth. Remember, this is what I call an alligator mouth because it looks like a gator. Okay, so we have -8. If you plug in -8 up here, so here's my test notation. If you plug in -8 inside the first parentheses, that'll be -8 minus 1, which is negative. Let me not put -1. Let's just put a negative in parentheses. What about this parentheses? -8 plus 7, that's also going to be negative. And we want to see if it's greater than 0. I mean, less than 0. What's a negative times a negative? A positive. Will a positive be less than 0? Absolutely not. So you will not shade here and here. Let's test 0. Plug a 0 into your first parentheses. So we have a parentheses times a parentheses less than 0, right? You plug a 0 into your first parentheses, you get a negative. You plug the 0 into your second parentheses, 0 plus 7 is +7, so that's a positive. What's a negative times a positive? Generally, it's a negative. Is a negative less than 0? Absolutely. Now, because 0 worked, we're going to shade where the 0 is, which is in the middle between -7 and 1. Spoiler alert, if the left side worked, the right side, the left side didn't work, but the right side did, the middle side did, then this over here isn't going to work. But let's go ahead and do it. It's really quick. We really shouldn't assume. I'm giving you guys bad habits. That'll be a positive when you plug in a 2 into here. That'll be a positive here. A positive times a positive is a positive. Is a positive less than 0? No. So it's not less than 0, so we're not going to shade here. We're done. What symbols are we going to put here? The symbols depend on this guy here, the less than symbol. So it's not equal to, so we're going to put parentheses. So your interval notation, and no, whatever. Your interval notation is going to be whatever your graph is, -7 to 1, bind it together. So -7, 1. Oops. Excellent. Okay, so let's look between -7 and 1 with parentheses and not a bracket. So -7, I don't see it right offhand. Where the heck? Oh, it's because it's right there. Yeah, that's it. All right, they're going to make us do just a little bit of work. We're going to go ahead and factor it up. Get this, make sure that the 0's on the right hand side, and we're going to handle business. So we have x squared minus 12x plus 35 less than, greater than 0. Factor it up, factor it up. X and x. The plus means the signs are going to be the same in these. They're both going to be whatever this is minus. Look at my factoring video. Anyway, factors of 35 that will give you 12 with 7 times 5. Yeah, that's it. Because 7 plus 5 is 12. So these are our key players. Oh, let's write the key players. X equals 5 and 7. So put your 5 here, put your 7 here. And we're going to start testing. Here's a fun fact. I had this in my calculus class, right? And I was in high school. And we were supposed to test these values like I'm showing you now. Like choosing the 4, I'm choosing the 6, and I'm choosing an 8. And I had somewhere to go. Somebody needed my help for something. I can't remember. It was something to do with the guitar or something. I'm also a guitarist. And basically, I just stopped here and ran out of the class. Like, it was a test. And I just ran out of the class, and my teacher showed me that, look, man, you wasn't done, but I'm not going to fail you. I basically deserved to fail, but he let me slide and he let me finish. I was like, oh, shoot. It was something similar to this. It was called U substitution. Anyway, if you guys are in calculus, I'll show you in the future. if you ever take calculus. Anyway, we're going to take the 4, plug it in, take the 4, plug it into here, and see if that's greater than 0. Remember, we're testing for the 4. So what is what did I do? This is 4 minus 7 greater than 0. Sorry about that. All right, so 4 minus 5 is a negative. 4 minus 7 is going to give you a negative. What's a negative times a negative? It's a positive. Is a positive greater than 0? Yes. So you're going to shade where the 4 is because 4 was actually true to the inequality. Let's try the 6. If you plug the 6 here, you're going to get a positive. You plug the 6 here, you're going to get a negative. We want to see if this is greater than 0. What's a positive times a negative? It's negative. Is a negative greater than 0? Absolutely not. You will not shade here. Quickly, let's plug in 8. Plug an 8 here, it's going to be positive. Plug in 8 here, it's going to be positive. Positive times a positive is a positive. Is a positive greater than 0? Yeah. Shade everything there. We're almost done. So depending on the symbols rely on whatever the inequality is. And there is no equal sign, so we're going to put parentheses. Now, I'm not sure if you can see through all this mess, but the graph looks like this. Maybe I should stop using red. Or maybe I should stop using just one color, because this is our interval notation right here. So from left to right, negative infinity to 5. Union with, because there's a big space, there's 7 to infinity. And that's it. Union with. Excellent. Okay, the graph mostly looks like something like this. We have 5 and 7. Yeah, that's it right there. It matches with our graph. Fantastic. All right, let's keep going. All right, check this out. This is going to be a special one. So let's go ahead. All right. I'm flexing. I know I'm flexing right now, but let me show you how we even get that. This is no solution, so it's going to be an empty set. Let me show you how I did it so quickly. And it's only because, you know, I've been through this. I've you know, learned a couple things on the streets, the math streets, not the real streets. Anyway, so what you do is you factor it up, right? So you get x and x. The signs are going to be the same because this is a plus. They're both going to be whatever that is. Factors of 16, I'll give you 8. That's 4 and 4, isn't it? Now, check this out. You get the same solution on both sides, right? You get a 4 over here, so your key player is definitely a 4. And there's no need to write it twice because it's the same number. So when you make your number line, you're only going to have one key player, and you only have 2 regions to test this time. So, how do we go from here? We're going to choose something to the left like we've always done. Let's choose 1. Why not? You can choose anything to the left of 4. And what about the right-hand side? We can choose 5. And let's see, if you plug a 1, I want to go back up to here and show you something before we start plugging stuff in. These 2 binomials are exactly the same, aren't they? So couldn't we, I don't know, say this is a binomial squared? Absolutely. When you square something, when you ever get something less than 0, absolutely not. Whatever you plug in here for x, once you square it, it's going to be a positive, right? Don't you square something and it turns into a positive? So it will never be less than 0. Now, there is a chance that it could be equal to the 0 that we have there, so you don't want to just start assuming things. So let's keep on going. We're going to substitute. We can substitute either here or here. They're both the same equation. Remember, you have an option. You can even substitute inside your original if you want. So let's choose the one with the parentheses. We're going to choose the middle one. So because it has parentheses, and we could just multiply. You plug a 1 in here. 1 minus 4. So we're plugging in 1. 1 minus 4 is negative. I keep putting negative 1. 1 minus 4 is negative again. We want to see if it's less than 0, and that is no. Negative 10. Did I just put a negative 1 again? Just the negative. Okay. Negative times negative is a positive. Is it less than 0? No. So we're not going to shade to the left. What about to the right? You plug a 5 in. Plug a 5 in here. That's going to be a positive. Times another positive, which would be less than 0. No, it will not, because a positive times a positive is positive. Positive will never be less than 0, so you're not going to shade to the right. So we have a little predicament here. Will it be equal to the 4? No, because we do not have an equal sign here. So because we don't have an equal sign there, you can imagine if there's an open circle. So we have all this open space. We have nothing solid, so that's why it is no solution. This is what they call an empty set. So on this graph here, it's just a bare naked graph. I guess we could put a 4 there, but you're not going to shade anything. So that's how we got this. All right, next. Okay, 2x squared minus x, and then less than 10. Yeah, they're making us work, but it's all good. We have 2x squared minus x less than 10. Now, if you've been noticing the trend, we always had a 0 over here, right? So let's move everything from this right side and bring it over here with the other guys, because we need that 0 sitting there. Now, can we factor this? There's a good chance that we can. You can use the quadratic formula to get your solutions if you want, but it's kind of a drag. But you know what? Let's go ahead and use one of my factoring methods. So here's how you factor this. First of all, we're going to use equality. So change it to an equal sign. And here's what I do. I take off the 2 and multiply it with the c term. Then I attempt to factor this portion. Let me make sure I'm doing everything correctly. So negative x minus 10. Yeah. Oh, Yep. I just said that we're going to multiply the 2 we took off from there and bring it onto here. 20. This is more like it. Let's factor normally. X plus x minus, because you have a negative number. The only way you can get a negative is with a positive times a negative, or a negative times a positive. It doesn't matter which one you put first. So factors of 20, that would give you a negative 1. Let's use the dot man method. Divide by 2, multiply by 2, divide by 2, multiply by 2. 5 and 4. Where would the 5 go? Where would the 4 go? Remember, the bigger number in the middle takes the sign. The number here in the middle is a negative, so make sure your bigger number is also negative. So your bigger number should be the same sign as your b term, which means the 4 goes here. We're almost done. Remember, this is a weird problem. We took the 2 off. You're gonna have to bring that 2 right back. So it comes from here. Not only does it multiply with the 10 to give you 20, but it also comes back down here and you divide. I know it looks weird, but if you practice this factoring method, there is nothing you can't factor. All right, so over here, we're going to have, you can leave this as x minus 5 over 2. But here's what I want you to do. You know 5 can't go into 2. Do me a favor. This isn't technically mathematical. I want you to bring that 2 in front of the x, so we don't have any fractions anymore. I promise you it works every single time. All right, anyway. So we can go ahead and bring back our inequality symbol. We have x plus 2. Then we have 2x minus 5 less than 0. Remember, I'm getting that from here. We're still doing less than 0. So, what is our solution? Let's get our solutions first. We have the opposite of this, which is negative 2. So x equals negative 2. And you can say we can take the opposite of this. We get 5 over 2. If you went on ahead and brought that 2 over, just go ahead and take the 2x minus 5, set it equal to 0, add the 5 to both sides, divide both sides by the 2, you get x equals 5 over 2 again. So just want to let you know it's consistent. Don't worry. Now, I'm going to need some room because this was kind of insane. So I'm going to erase some of this stuff. and I only want right to where I factored. So let's just erase everything here. Okay. So right up in here, x plus 2, or you can use the original because we're going to start testing right now. So okay, let's put our key players down. So we have -2, and we have 5/2. Let's go ahead and use a decimal because we want to know where that is with respect to -2. We know it's positive, so it's somewhere over here to the right. But let's use a decimal so we can be more precise, so we can get proper text fixtures. So I just said text fixtures. That's what we say at work. We have text fixtures at work. Anyway, 5 divided by 2 is 2.5. You know, that's half of 5, $2.50. Right? So remember, you can do... Yeah. So anyway, test numbers. What's in between? 0. What's to the left? -3. What's to the right? +3 or 4 to be safe. Okay, we're gonna plug all these numbers into your original. Ready? So we're testing -3 right now. You know what I'm gonna do to make it a little bit neater? I'm gonna go ahead and chop it up like this. I've seen someone do this before, and it's nice and neat. So you can see this is the -3 region, that's the 0 region, that's the 4 region, right? Okay, so we're gonna plug in -3. We get a negative in the first parentheses. I'm not putting a number. What am I doing? We're gonna let's see. -3 times 2 is -6. -6 minus 5 is also negative. And we want to see if this is less than 0. What's a negative times a negative? It's a positive. Is a positive less than 0? No, it is not. So we will not shade. Let's plug in 0. Plug a 0 in here. We get a positive. Plug a 0 here. 2 times 0 is 0. 0 minus 5 is negative. And we want to see if this is less than 0. Positive times a negative is a negative. It's less than 0. Yes. So we will shade in between here and here. Spoiler alert, we're not going to shade over here, but let's plug in a 4 anyway. Plug in a 4, positive. We get a positive there. Plug a 4 here. That's 8 minus 5, which is also positive. What's a positive times a positive? Is positive is a positive less than 0. Never. We're done. So the two cutoff regions depends on whatever this sign over here is, this inequality symbol, and it's not equal. I wonder why we haven't gotten equals yet. It's not equal, so we're going to use a parentheses. So the interval notation will be -2 with the parentheses, comma, 2.5, which we know was 5.2. So, let's put that here. I mean, 5/2. You know what I mean. So same thing, tomato, tomato. All right, so let's go ahead and put that solution in. This is -2. Why does it always do that? That's so annoying. This is -2. And then you got to hit the arrow twice to make sure it's in the box. Good job. Okay, whichever one closely resembles our graph. See the importance of putting 2.5? So we know that's 2.5. It could be that. Yeah, it's this one. Oh, no, it's not, because we have a shade in the middle, not on the ends like that. So it's this one. Yeah, -2, -2. We have 2.5. We have 2.5. Yeah, that's it. Nice work. Let's keep going. And this is all they're going to do. They're going to give you different cases. You have to know how to manipulate the functions in the equations, and you should be okay with enough practice. All right, so let's go ahead and do this. So we have 10x less than or equal to. Finally, we have an equal to inside of here. We have a. Finally, did we ever have an equal to? I don't think so. Anyway, all right, we're gonna bring this 10x over so we can get a 0 on the left hand side. So we get 0 is less than or equal to 8 minus 3x squared minus 10x, right? Now, here's the way I want to do it. I want to do a couple things. We're still going to have 0 is less than or equal to. Let's put this in descending order. We get negative 3x squared plus 10x plus 8. I'm sorry, minus 10x. Let me erase that. It's still a negative. And then plus 8. Okay, I want to do something special with this one because I personally don't like for my leading term to be negative. So I'm going to multiply every term by -1. And when you do that, you're going to start flipping the signs as well. So bear with me here. The 0 is still a 0. We're multiplying by -1, so we're going to flip the sign. This becomes positive. That becomes positive. That becomes negative. Can you factor with the negative? Yeah, it's not a general practice that I like to do. I like to factor when the leading term is positive. So we have 0 is greater than or equal to 3x. Okay, so look at this as well. We have the 0 on the left-hand side this time. You know what? It's still going to be okay. But if you don't like it there, we're going to rearrange it. 3x squared plus 10. As a matter of fact, I recommend you stay consistent. Minus 8. Now, this alligator right here. Remember, we have an alligator. It has teeth. And it has 2 eyes. It's looking and it's angry, right? You want to make sure the alligator is still pointing towards what it was pointing to here. So the alligator is pointing towards the 0. So make sure it's still pointing towards the 0. Okay. So, as a matter of fact, I think the gator is lost. So yeah, they're really angry. All right, anyway. Jab. I took a jab. Okay, anyway, let's go ahead and factor this. So we're going to use my little method. Take off the 3. We get x squared plus 10x. Multiply that 3 by that. We get -24. Let's go ahead and factor it up. I'm going to keep the same symbol. You don't have to change it to an equality, but I know your professor probably been teaching you that. Yeah, we're just going to stay consistent, I guess. What the hell? Let me erase that. That's supposed to be a 2. Come on, Dan. Okay, factor it up. X and X, factors of 24, that'll give you 10. Let's use the dot man method, divide by 2, multiply by 2. Got it, 12 and 2. Oh, it's going to be a positive and negative because your C term is negative. 12 and 2, bigger number takes the sign, so it's going to be the same sign as the middle. So that's 12 and that's 2. Now we have to bring back the 3. We took the 3 and multiply with the 8 to get 24. We're going to take the same 3 and divide both of these by that 3. 12 divided by 3 is 4. Easy enough. You know 2 can't go into 3, so we're going to bring that in front of the x and call it a day. So we have our factored form right now. I'm going to erase everything, and I'm just going to write the factored form. Because that's really the most important thing. Okay, so this is x plus 4. This is 3x minus 2 less than or equal to 0. So, yeah, let's just go ahead and start testing values and put in our key player. What is our key player? We have x equals -4 is a key player. What about here? Just set it equal to 0 and solve for x. 3x is equal to 2, so x is equal to 2 over 3. That's another key player. And we can go ahead and make a little number line like so. Put your key players down. We have -4, which is over here, positive 2 over 3. So please don't make the mistake of putting 2 over 3 over here on the left and -4 over here on the right. That's going to spell disaster. Okay, because it should be from least to greatest, right? When you go from left to right. Give me a number in the middle, 0. Give me a number to the left, -5. Give me a number to the right, 3, maybe. Yeah, definitely. 3 is greater than 2 over 3, right? No, baby. Okay, so let's save some time here. I want to show you a little trick. There's nothing funny about this fraction. It's not squared. It's not a perfect square binomial like the last time when we had no solution. So we're going to save a little time here. We're going to test just one of these. And based on that, we're going to judge our answer. And we're going to get it right. I can guarantee it. So let's plug in the 3. So I'm going to make some cutoffs right here for that region. Plug a 3 in. You're going to get, let me use red. All right, so you plug a 3 in. You're going to get a positive. In this parentheses, plug a 3 in here. That'll be 3 times 3, which is 9. 9 minus 2 is positive. We want to see if it's less than or equal to 0. What's a positive times a positive? A positive. Is a positive less than 0? Never. So guess what? The middle is the only thing that's going to work here. And this may be a bad practice. We may be naughty going against the grain, but you know what? It works for me. It can work for you. The left side is not going to work neither. And you can do it quickly. That'll be a negative. That'll be a negative. Negative times negative is a positive. Positive less than 0? No way. So we're not going to change that. And this is the way I do it. Let's plug in 0 just to be absolutely sure. Plug in 0 here, that's positive. Plug in 0 here, that's negative. Positive times negative is negative. Negative is less than 0. Yep. Now, what symbols are we going to put? The symbols that we put depends on whatever this is here. So brackets, because we finally have an inequality, and that looks weird, I'm going to use lime so it can pop, so it can stand out. And this is our solution. So interval notation is going to be bracket -4, comma 2 over 3 with a bracket. We're done. Okay, so well done. Okay, whichever one closely resembles our graph in green. So we should have -4 on the left with a bracket. Looks like that's it right there. Yeah, and it's hit 2 over 3. Gotta be it. Yeah. All right, over here, let's keep it moving. This is a special case because we don't have a C term here, do we? We have x squared plus 7x. There is no C term. We say this is greater than or equal to 0. So let's go ahead and start factoring it out. We have a GCF. We haven't had one like this in a while, but you can take out an x. Why not? We get x plus 7 greater than or equal to 0. So you know what comes next. Number line. What are our solutions? You know what I want to do? I want to wrap this x I factored out in parentheses because we had parentheses so much. You can put it in parentheses. Why not? You can always wrap a number in parentheses at any given moment if it helps, or you cannot. It's up to you. What are our key players? Well, we have an x out, so when you set that equal to 0, you get x equals 0. What about here? What's the opposite of that? -7. There goes our, or I should say, there go our two solutions. My English is not very good. Okay, we have -7. We have 0. Test values. Give me something between -7 and 0. -5. Right? How about a 3 here and a -8? We're going to have some cutoff regions. Yeah, I'm going to adopt using that. It looks so nice with the, it's like I'm making football plays or something. Like, yeah, we're going to go here and then we're going to do that and then you're going to have the X and that. All right, let me stop screwing around. Okay, yeah. Okay, so let's start testing. So we have -8. Let's plug it in here. We get a negative, right? Just -8. Plug a negative here. -8 plus 7 is also a negative. And we want to see if that will be less or greater than or equal to 0. What's a negative times a negative? It's a positive. Yes, a positive is greater than 0. You're going to shade. We're not going to waste time. That side over there is going to work. Depending on what this is, those are the symbols we're going to put down here at these two key players. We're going to put brackets there because it's equals. And it's really that simple. I know you may seem like a little robot, like you're just a part of some crazy machine and you don't know what's going on. But really, it's repetitive. This stuff is really repetitive. Oh, so interval notation. The solution is going to be -infinity to -7, union with, because we have this big space here, 0 to infinity. So in this chapter, they took stuff that we learned from compound inequalities. You know, that's fancy for saying, that's a fancy way of saying two inequalities at once. Your manipulation of, oh, did I just put a parentheses there? We're supposed to put a bracket. Why didn't you guys say something? All right, anyway, yeah, so they took a couple, you know how math classes are. They take something, they give you a concept, and they bring it back up, hoping that, you know, to test to see if you retain some of that prior knowledge. Like we learned complete the square way back when, and then it popped back up again when we were dealing with parabolas. Well done. All right, which one? So we have opposite ends like this. So there's our -7. There's a 0. Yeah. Yeah. Got it. Well done. This is going quicker than I thought. All right, so -7x squared. Let's go ahead and knock this thing out. All right, let's use orange. -7x squared minus 7x is greater than 0. What's the GCF here? What can you divide both of these by? We can divide them both by 7, a -7 as a matter of fact. And we can also divide by x. So let's close it up. -7 divided by -7 is 1. X squared divided by x is just an x. And you know a negative divided by a negative is a positive, so it works out. Over here, we have a negative divide. We took out another negative from here, so that's going to be a positive now. Be careful. -7 divided by a -7 is a 1. X divided by x is also 1, so we get x plus 1. Key players. This -7x here, there's no plus or minuses coming after, so you know what? This is going to be, you can think of it as -7x equals 0. Divide both sides by -7. You get x equals 0. For one of your key players. You can even ignore the -7 as a practice and say, okay, this thing multiplied with this thing here will give you 0, right? If you ever just get an x or a 2x, a 3x, a -7x or whatever, yeah, one of the solutions is going to be 0. All right, so that's one of our key players. What about here? Opposite of this, -1. Okay, so let's go ahead and make our fancy number line. We have 0 and -1. The -1 will be here, and the 0 will be somewhere here, right? So let's go ahead and do our test points. Give me something between -1 and 0. That would be -0.5, -0.5. But you know what? If you're not too good with the numbers, let's do the opposite ends first. And I don't like fractions like that. Who the heck likes fractions? I mean, you know, I met a kid who likes fractions, and I'm going to say more power to him. Let's hope it stays like that. Us adults, we complain a lot. The kids are the future. Let's just not rain on their parade. Let's just keep it positive, because they are positive in the beginning. Okay, so let's plug in +4 because it's a positive number and positives are nice. So if we plug the -4 in here, you know, I'm going to wrap this thing up in a parentheses. If you plug a +4 in here, sorry, if you plug a +4 in here, you're going to get a negative because it's -28, so it's negative. Plug a +4 here, it's going to be a positive. And we want to see if this is true. What's a negative times a positive generally? That is a negative. Is a negative greater than 0? No. You're not going to shade here to the right, which means you're not going to shade here to the left, which means you're only going to shade in the middle. So, Yep, so what symbol do we use? The symbols depend on what this is. It's not equals, so we're going to use a parentheses. So you can see it better, I'm going to use the trusty line and shade just like that. So that should be your final graph right there. Interval notation is going to be -1 to 0, not included. So with parentheses. So parentheses, -1 to 0, close that thing up. Got it. Fantastic. Graph looks like this. So -1 and 0. Where is it? Yep. Right there. Stuck out like a sore thumb. All right. So 2 more to go. I think this we only had 12 questions on here, so let's just keep it moving. Uh-oh. I can tell this is not going to be nice. They're going to make us work for this interval notation here, because I can see that it's not factorable. You bring everything over to the left. There are no factors of 1 that would give you a 4. So we're going to have to do some quadratic formula nonsense. But let's be quick about it, since you guys already did the quadratic formula before. And while we're here, I'm going to move the 4x over to the left. And I'm going to move the 1 over to the left. And this is less than or equal to 0. All I did was move them over, right? So I can get my 0, my precious 0. Now, because this thing can't factor, there are no factors of 1 that will give you a 4 in the middle. So whenever that happens, this is a quadratic formula. Remember, there's a 1 here. So our A is equal to 1. Our B is equal to -4. And our C is equal to -1. So, quadratic formula. So x is equal to -b plus or minus big old square root b squared 16 minus 4 times your a times your c. Everything is all over 2a. Your a is 1. All right, step by step. Negative times negative is a positive. This is a 4 plus or minus. This is a negative times a negative, which is a plus. I'm going to change both of those into pluses. 4 times 1 times 1 is just 4. 16 plus 4 is a 20. See how we did that? 2 times 1 is 2. Almost done, I promise. This square root of 20 right here, can it be broken down? Possibly. What times what we give you 20? Oh, and this is a square root, so you need 2 of the same number, so I'm going to put a 2 there. Normally the 2 is not there. Okay, so what times what we give you 20? That is 10 times 2. What times what we give you 10? That is 5 times 2. The square root wants you to take 2 of the same number. So do we have 2 of something? Yes, we have 2 2's. Circle them both, bring out 1. What couldn't we circle? What didn't have a pair to go with it? The 5. Leave it in. So this is 4 plus or minus 2, radical 5. All over 2. Man, this is insane. Are you still hanging with me yet? All right. So we're almost done. These are 2 separate solutions, right? Because they're both over 2. So couldn't you just separate them? 4 over 2 plus or minus 2 radical 5 over 2? Yeah, you can do that. Why not? Because if you do, you can see that they're going to cancel. 4 divided by 2 is 2 plus or minus 2 over 2. That goes away. Radical 5. This is x equals to that mess. So your key players, which is so messed up, your key players. And before I graph it, let me make sure I put what the key players are. X is going to be equal to 2 plus the square root of 5, wherever the heck that is, and also 2 minus the square root of 5. And we can't quite combine them because we don't have a calculator right now. But it's okay. It's like which one goes where? Well, the top one, remember, you can put this in your calculator. You know what? We will. All right, let me make sure you guys can even see the calculator. Okay, got it. All right, so let's put 2 plus the square root. So we hit second square root. 2 plus the square root of 5. What the heck is that? 4.23-ish. Or 4.24 when you round it to 2 decimal places. So I'm going to put 4.24 right here. And this is 2 minus the square root of 5. So you can go up here, hit enter, or you can just type it in regularly. I wonder which one would have taken less steps. This is negative 0.24. So negative 0.24. Let me make sure you guys can even see what I'm writing. Oh, you cannot. But yeah, I wrote them down so you can look at the calculator if you like. Okay, you're done? Okay, good. Okay, so you can rewind. Okay, so let's put these down. Technically, this is negative 0.24. It's negative, so it's over here to the left somewhere. This is positive 4.24, right? So remember, they came from the radical form, so we're just using this just so we can test them some values and stuff like that. Speaking of which, let's start testing. And we're going to plug this into the original equation to see if this less than 0 thing is true. So I'm only going to use 1. As a matter of fact, to make life easier, I'm going to just test the 0 and nothing else. If the 0 fails, then the other two ends are going to work. If the 0 works, only the middle will work, because 0 is in the middle. Anyway. Let's plug the 0 in. We get 0 minus 0 minus 1. We're left with -1 is less than or equal to 0. Is that true? Oh, yes. Yes, it is true. -1 is definitely less than 0. We're going to shade. If you want to, you can plug in a 5. Like, why not? You can test the 5. This is going to be very big. That's going to be 5 squared, which is 25, minus 20, which is 5. 5 minus 1 is 4. 4 is less than 0. We already know that that other side wasn't going to work, and neither will that one. But just for a reference, we can choose like a -2 maybe. But yeah, the middle worked. So only the middle will work. We don't have a binomial squared or something crazy like that. So we're done. Now, the symbols depends on, let me come over here, whatever the heck this is. So we're going to put brackets there. Let's put it in lime so it's popping. And we are done. Now, remember, negative 0.24 is actually 2 minus the radical 5. And positive 4.24 is the positive 2 plus square root of 5. So make sure you put that as your solution set. So your interval notation, remember, we only use the decimal so that we know where they fit on the line. Interval notation is bracket, the negative version, which is negative 2.4, right? Is 2 minus the square root of 5, comma, 2 plus the square root of 5. Did I just put plus and minus? Yes, I did. With a bracket. And that is it. Solution set. Let's go ahead and do it. We have 2 minus the square root of 5, comma 2 with a bracket plus 2 square root of 5. Close that thing up. Oh no, I'm still underneath the radical. Excelente. Okay, and they look how nice they were. 2 minus radical. Yeah, that's it. With the 2 brackets. Got it. Fantastic. Looks like we have one question left. Find the domain of the function. Okay, the domain of the darn function, eh? We got this. Don't worry, guys. They're just trying to scare you. And gals. They're just trying to scare you guys and gals. Okay, so what do we know about the domain? Well, we have f of x is equal to the big old square root of 4x squared minus 33x plus 54. How do we find a domain of a square root? Well, a square root on the inside cannot be negative, right? So all we do is take out whatever is inside that radical. I think they call that the radicand. I don't know. Look at my old videos. I'm not too big on vocabulary. Anyway, mathematical vocabulary. A square root cannot be negative, flat out. So set the inside of this greater than or equal to 0. Any questions? All right, good. Because that's how you find a domain for every square root function. Anyway, so we have this thing now. It looks very similar to what we had before. They're gonna make us work for this crap. So I don't wanna do my method and find out that it can't factor. You know, let's do the darn method. Excuse me. All right, ready? We're gonna take this 4. Because it's troublesome, we're going to take the 4 and we're going to multiply by our c. This is a form of AC method. So we have x squared, we took it off, minus 3x, plus 54 times 4, that is a 216. Holla at your boy. Okay, so let's see if this is factorable. So remember, no number is too large for us if we use the dot man method. Remember, click on my very first video if you have the time in your life. I can factor anything. I can find factors of anything, and I can get you to find all the factors of anything. And all you do is divide by 2, multiply by 2. or divide by 3, multiply by 3. Choose the smallest number, right? So let's divide this thing by 2. We get 108. Let's multiply this by 2. We get 2. Divide by 2. Multiply by 2. Divide by 2. Multiply by 2. Divide by 3. Multiply by 3. Divide by 3. Multiply by 3. 24 times 3 is 72. I'm in math mode today. I don't know what's going on. All right, we can't divide the 3 anymore, so we're going to jump over to the 72 and do the same routine. Divide by 2, multiply by 2. No one does it this way, by the way. No one has ever come up with a way to find all the factors of a number. That's me originally. That's my gift. Hopefully I become famous someday. I got to get the right exposure, though. So you're not going to find this anywhere else. I came up with this on my own, believe it or not. Divide by 2. Multiply by 2. Let me stop bragging. Divide by 2. Multiply by 2. Divide by 3. Now, if you were to divide by 3, wouldn't you get a 9 again? If you divide this 9 by 3, wouldn't you get a 3 again? So, like, those are all the factors of 216. But we didn't come here for all of those factors. We came here for a 3. And you know what? Let's go ahead and make sure that that they're correct. Is 6 times 36 equal to 216? Yeah. But which one of those would give us a -3? Looks like none of them do, which sucks, man. I was ready. Let's see. We have 18 and 12. We're adding to get 3 as well. So nah, sadly, none of them will. So this thing right here is not factorable. So now what? Looks like we're forced to use a quadratic formula again. And I was excited. Doesn't that suck to just find out that the thing is not factorable? Unless I made some kind of crappy mistake, and if I have, I'm going to have to be forced to make another video. But let's take it from the top. And we're forced to use the quadratic formula, so we took it out. So down. Okay. Our A is going to be 4. Our B is -33. And our C is 54. So quadratic formula, -b. This is x equals -b plus or minus big old square root b squared with whatever the heck that is. We're going to put all this stuff in the calculator. Dear God. 4 times 8 times your C. This is a 5, guys and gals. All over 2 times your A, which is 4. Man, oh man. Okay. Calculator time. So we have... we can go ahead and... Oh, let me let you guys see the calculator. Okay. So we can put a 33, x equals 33 plus or minus. And we're just going to put the results of everything. We know this is all over 8. So the most complicated part is that inside portion, right? So this is -33 squared, which is just like saying we have a positive 33 squared because it ends up being positive no matter what. Minus 4 times 4 is 16. I'm going to put 16 times 54 and see what we get. 225. Wow, it actually ended up being a perfect square. The square root of 225 would give you a 15. Very nice, I guess. All right, so this is 15. So let's turn off the calculator. Okay, so this is 33 plus or minus 15 divided by 8. So what is 13 plus 15 divided by 8? Well, the first solution is 33 plus 15 over 8. Let's see, that's an 8, that's a 4, that's 48 over 8. What the heck? I actually got a solution. I gotta do that problem over. Okay, let's do the minus. Yeah, we didn't have, what the heck? That means that I actually, what? I'm so confused as to how oh, it's because the B term, no, the B term was -33. I'm gonna have to do that again in the future, guys. We could have factored that last problem. We needed a 33, not a 3. Why did I just put 1, 3? Anyways, man, I'm slacking. 33 minus 15. Oops. Minus 15 over 8. 33 minus 15. My mental math is not that great. I'm going to use a calculator right quick. Give me 1 sec. 1 second. I probably could have figured it out by now without using that. All right, 18. Oh, it is a fraction. It's still a fraction, yeah, which is to be expected. This is 18 divided by 8, which is 9. Divide the top by 2, you get 9. Divide the bottom by 2, you get 4. So there goes our key players from all this mess right here. So I have to erase, some of this stuff here. Man, because we have our key players and that's all we need. Erase all that quadratic formula junk. Man. I want to do something crafty. Because we just went through the trouble of factoring and we got the solutions, how about we write it in factored form? That'll be x minus 6. And then x minus 9 over 4 is the opposite of what we have down there, right? This is legit. And if your professors give you crazy looks, take that 4 and bring it up to the x if you want to. All right, number line. All right, key players is going to be, we already have the key players here. We have a 6 and a 9 over 4. Which one is larger? If you do 9 divided by 4, let's see, 9 divided by 4 is 2.25. So we're going to say this is 2.25, okay? So where will they go with respect to one another? We're going to put the 2.25 here, which is 9 over 4. We're going to put the 6 over here. So in the middle, so we know this is also 2.25. So what's in between 2.25 and 6? We can choose 3. Why not? Oh, we put test values in red. Give me something to the right, 7. Give me something to the left. Let's choose 0. 0 is always nice. So here are your regions. Let's plug 0. You plug a 0 here, you're going to get 54. So is 54 greater than or equal to 0? Yes, it is. So we're going to shade here, which means this right side is also going to be a solution. The symbols depend on whatever symbol we've been using the whole time. So we're going to put brackets there. And we are done with this one. So the interval notation, I'm still bummed out that I made a bonehead mistake a little while ago. Such is life, I guess. I need to get better. This is 9 over 4 with a bracket. Union with 6 to infinity. And we're done. All right, so your domain is going to be negative infinity with 9 over 4. Oh, with a bracket, right? Six all the way to infinity with a parentheses. Well, freaking done. That is it. We are done. Thank you so much for watching. That's it for this week with college algebra. It's been quite the journey. If you have any questions, please put them in the comment section. Thank you very much. You are free to go home.